It's certainly the case that you can integrate things that fall into this arena of integration by substitution without actually using integration by substitution. If I can take you back, I'm just going to make one up. When we first learned about integration, or we didn't call it integration at the time, we called it anti-differentiation. It was kind of a trial and error thing. So we were told we had things like f of x equals 3x plus 2, and at that time we were using this kind of archaic notation for the antiderivative. So we reasoned out, for example, that the antiderivative of a term that has a degree of 1 must contain a degree of 2, because when you differentiate a quadratic, you get a linear. And then you kind of reverse engineered this, and you said, wow, this must be 3/2, and this must be 2x, and you put in your constant. And that should be no problem for everybody. But then there was an example, a set of 2 examples we did in class, and then there was an assigned problem as well connected to this, or set of problems, where you had stuff like the following. And you had to find the antiderivative of it, and I gave everybody a couple of minutes to ponder it, and a couple of you figured out what to do. It was that you kind of ignored the cosine of x, and you looked at the bigger picture being the cube of a sine of x. So you said, well, what if I do this? What if I just kind of ignore the cos of x? And if you differentiate that, I can throw in my c if it's bothering you. If you differentiate that, what's going to happen is you'll move that 4 down in front. It'll cancel with the quarter. You'll be left with sine cubed. But then the chain rule says you have to multiply by the derivative of sine, which gives you the cosine. So what we have learned yesterday is that if you want to determine this, there's a formal process that you go through. You say to yourself that I'm going to choose u equals sine of x, which means that this part here, it means that this part here is going to be written as u cubed in the next step. We're replacing the argument of that power, the argument being sine of x, with u. And then we say to ourselves, well, what is du? The derivative of u is cosine of x dx, and that means that this is going to be replaced with du. Pardon me. No, that's right. That's right. So now what your integral becomes is the integral of u cubed du, and that's easy. That's 1/4 u to the 4 plus a constant. So now what we can do is we can put the sine of x back in. And this is what I meant when I started off today by saying certainly there are many problems that would fall into this area of using integration by substitution. You don't really need to. You can look at it and reason it out. But as you get deeper and deeper into calculus, there will be problems that you need to do the substitution to see what's going to happen. Okay. So all that being said, does anybody have any questions here that you would like me to go over from yesterday's assigned problem set? Go ahead, Cyrus.
4b.
Did you say 4b? Certainly. See, this is one that I don't really think you need substitution to do. when I look at this, and let's forget about the fact that it's a definite integral with 0 and 2 in it. I guess I won't forget about that. I'll put it here. But that's not what our concern is, I don't think. When I look at this, I see 1 plus 5x raised to the negative 4 dx. So I know I tell you don't work left to right, but I'm just going to do it for the first step, and then I'll work down. In my mind, I'm going to say that this will be equal to 1 plus 5x raised to the negative 3. I'm doing the opposite kind of thing that I would do when I differentiate. When I differentiate, I lose 1 for the exponent, so when I anti-differentiate, I gain 1. But then I say to myself, if I differentiated that, it's going to give me the following. So this is what's going on kind of in my head or off on the side on scrap paper. I'm saying that the derivative with respect to x of what I believe the answer is would be negative 3 times 1 plus 5x, and I'm just going to pause right there before I go on. We don't want that negative 3, right? Raised to the negative 4, which we do want, and then times 5. So there's two numbers that come out of this. One is from the chain rule, one is from the power rule, and the two numbers are negative 3 and 5, which would give me negative 15, but I don't have a negative 15 here. So how you would do it, just by kind of reasoning it out, is you must say, I need to have a coefficient here of this. Okay, which means that this will be negative 1 over 15, 1 plus 5x to the 3, evaluated from 0 to 2. Okay, you're okay with that? But even though I don't think this is that difficult to wrap your head around and figure out without a technique, the technique is nice because, just want to make sure that's right, multiply that through, you get 1/5 times the 5, you get 1, it's all good. What you would do here is you would say u is 1 plus 5x. And that means that du is 5 dx. So what that means is dx is 1/5 du. And finally, what all of that means is this is going to be replaced with u, and this is going to be replaced with 1/5 du. And what happens then is you end up with the integral of u to the negative 4 times 1/5 du. Of course, it's not from 0 to 2 anymore because this is an integral making reference to u, not x. I am going to take just a little detour here just to remind you that if you did want to work with numbers for u, you're going from 0 to 2, and u is 1 plus 5x. So you can figure out what the new u, or not the new u, what the u lower and upper boundaries are. This is 1, and I think this is 7. No, 11. Right, put in 0 for x, you get 1 for u. Put in 2 for x, you get 11. So if you wanted to, you could do this. And as I said yesterday, I think this is actually a smarter move. It's going to make the calculation in the end easier. And then, this is a good question to review everything we've learned about this so far. You might as well take that 1/5 out because you can. And then you're left with an integrand, which integrating is really simple. Increase the exponent by 1, divide by the new exponent. And what you're going to get is 1/5 multiplied by u to the negative 3 over negative 3, and you're going to evaluate that from 1 to 11. And that's going to give you negative 1/15. I don't care how you write this. I'm going to write 1 over u cubed from 1 to 11. And I would certainly do this. I would calculate that and then multiply the whole thing by negative 1 over 15. Would you like me to go through the calculation? Okay. Any other questions?